Right, we're going to look at the next fundamental law of surds, and we're going to look at something called rationalising surds, okay? And this is quite an important skill. You might not necessarily see the point of it right now, but if you carry on studying maths into A level and sixth form, or university and so on, you'll see why this is kind of useful. It is a bit of an old-fashioned skill, but it's essential for some other things that are going to come up later on in your studies if you carry on with maths. Okay, you're certainly going to get examined on it in the GCSE. You're going to get questions like this, and you need to be able to do it. And you'll see how it makes life a little bit easier when you're working things out. Okay, now what's the principle behind rationalizing surds? Okay, the idea is we don't like having surds on the bottom of a fraction in the denominator. Okay, it makes it quite difficult to work with. So the idea is we're trying to change this surd so that it does not have a surd on the bottom. Okay, that's the basic principle. We're trying to get rid of the surd. Remember, the surd is just the square root part on the bottom of the fraction. Okay, because we don't like that there. In terms of calculations and working with it, it makes it a bit difficult, and we're trying to simplify it in essence, really, to try and get rid of that surd on the bottom. Okay, so how do we go about doing that? Okay, well, if we just go back to fractions, for example, and just think about how fractions work. If you had a fraction 5 over 7, okay, if I multiply the top and bottom by 3, okay, then it becomes 15 over 21, okay. Now, fundamentally, let me just, oops, oh, I didn't want to do that, damn it. Okay, let's do that again. 5 over 7 times 3, which is 15 over 21. Right. Okay, don't press that button. What was I going to say? Oh, yeah, sorry. If we look at these two fractions, okay, are they fundamentally different from each other? Well, in terms of the numerical kind of numerator and denominator, they are different, but actually their values are exactly the same. Okay, they're not different from each other at all. Numerically, number-wise, the number or the decimal that they represent is the same. Actually, I'll tell you what. Let me just quickly work it out. So, if you did 5 divided by 7 on the calculator, you get 0.7142 blah 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 blah. And if you did 15 divided by 21, you still get 0.7142 blah 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 blah. Okay, they both represent the same number. They're just different versions of the same fraction. Okay, so if you multiply top and bottom of a fraction by the same thing, it doesn't actually change it. Because technically speaking, if you times something by 3 over 3, okay, and you get 15 over 21, okay, well, if you analyse that fraction there, okay, what is 3 divided by 3? Well, that's just 1, okay. Multiplying something by 1 doesn't fundamentally change its value, okay. So effectively you are just multiplying this fraction by the number 1, which doesn't really change it, but in this case it just changes the number on the top and the bottom, but that fraction is the same as that fraction. Okay, that's the principle behind it. So we're going to do that here. Okay, so what we're going to do is we're going to times top and bottom by root 10 over root 10. Okay, you'll see why in a minute. Okay, I don't really care about this 9. That's not really a surd, it's just an integer, so I don't care about that. I just care about this thing here. I want to try and eliminate that. So the idea is we're going to multiply top and bottom by root 10 over root 10. But just keep that in the back of your mind. What you're really doing is just multiplying it by 1, which doesn't actually change the value of that fraction there. Okay. So how do you multiply fractions? Well, you multiply the tops and you multiply the bottoms. So on the top, okay, I've got root 3 times root 10. Okay, and that is root 30. Okay. And on the bottom, I'm going to have 9 times, and then I'll have a root 10 times root 10, and that'll be a root 100. Okay, but what is root 100? Well, root 100 is 10, and then if I multiply that by that 9, I get 90, so I get root 30 over 90. Okay, and this is the answer. Okay, I'll check that in a second, but let me just explain. Okay, so what we're saying is this fraction here is actually equivalent to this fraction. And I'll tell you what, I'm just going to type it in on the calculator to see what decimal it gets. So let's just do that. So, oops. So root 30 divided by 90. The decimal is, oh dear. Oh, actually, not so bad. It's 0.6. Oh, no, clear that. It's 0.0608858, blah, 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 blah. Okay. And then I'll type in this fraction on the calculator. Actually, I don't know why I'm doing that because I know it's going to be the same. But I'm going to do it anyway. You can't see this, but trust me, I am doing it. Okay, and guess what? Well, actually, if you got one of those really cool Casio calculators, it does just convert that to root 30 over 90. I forgot about that. The Casio has just told me it's equivalent to that. Casio thinks I'm an idiot because it's like, why have you just worked that out? You know it's that. Okay, well, it comes out to the same decimal. Okay, so what we're saying is this fraction, this surd fraction, is equivalent to that. This is what we call the rationalized form because there is no surd on the bottom. Okay, if we convert that. Okay, so the idea is we're trying to get rid of that surd off the bottom, and this fraction here is equivalent to the question, but there's no surd on the bottom. Okay, it's gone magically. Okay, so let's do another one. So here, for example, the trick is to just multiply top and bottom by root 13. Okay, because that's the surd on the bottom. So root 13, well, if you root 13 times 1 is root 13, but on the bottom, I'll have 5 times, okay, root 13 times root 13 is 169, but the square root of 169 is 13, so this is 5 times 13, oops, 13, okay, and then 5 times 13 is 65, so root 13 over 65 is the answer. Okay, and check that. Okay, got it wrong. Okay, it doesn't like that line there. It's probably because I forgot to code it, but that is the answer. Okay, so root 13 over 65. Okay, so that surd is equivalent to the question, but they're just rationalized. Now, I'm just going to kind of like fast forward this process really because I don't want to do more work than is necessary. So this one here, I'm going to times top and bottom by root 5. Okay. Now, in the test, do write that, okay? Don't just forget about it because you get marks for working out in case you get the last thing wrong, so do write it. So this one's going to be root 30, okay, over... Now, I'm going to skip a bit because I know on the bottom I'm going to get a 10 times root 25, but that's going to turn into 5, so I'm just going to get a 50 on the bottom, okay? And there you go, that's the answer, okay? All right, let's try another question. Actually, let's try and find one where not that one, yeah, this one here. Okay, right. Okay, actually, yeah, alright, I'll do that one. So we're going to times top and bottom by root 11. So on the top we'll get 2 root 22, okay, and on the bottom we'll get 8 times 11, so we'll get 88. Okay, just be careful because this is not the final answer. Okay, so remember what we did is times top and bottom by root 11. I forgot to write that, but we should do. Okay, and then on the top we get 2 root 22, and on the bottom we get 88. But the 2 and the 88 can simplify to 44. Okay, because just the 2 over 88 is equivalent to 1 over 44. So you don't need to write the 1, but that's the simplified thing. Okay, alright, so have a go at a few of these. Oh, and by the way, whenever you times the surd on top, like for example, if I had root something like 24 on the top and 6 on the bottom, okay, just remember that surd on the top can actually simplify to 2 root 6 over 6, and then that would simplify to 6 over 3. Okay, so just be careful. I will put some of these questions in, but that top surd could simplify to something, and then that number cancels something off on the bottom and you're left with this here. Okay, just be aware of that. Okay, thank you for watching.